So, welcome everybody to topic on PSM. As John said, primary storage manager. A little bit about me first. I've been working with Informix for almost 20 years. I've worked with every version since 5 up to the latest version of 14. Actually, just recently converted a client from 5 all the way to 14. I still actively am supporting several instances of SE. Unfortunately, PSM is not available for that version. Currently with XDB systems, so we'll talk a little bit more about that at the very end. And we'll jump right into it. So, Primary Storage Manager was introduced in version 12. They've made some incremental changes in version 14. They keep making it better and more efficient. So it replaces the old ISM. If you've worked with ISM, you know that it's kind of painful, kind of slow, really complex, and it was not an easy tool to work with. So this is the old storage manager that came bundled with Informix. PSM is the new version of it, completely written from the ground up, far more efficient, far easier to use, faster, all kinds of good stuff. So what a storage manager is, if you have not worked with one before, it uses the onbar utility from Informix to do backups, and it will connect to a storage manager. There's lots of external ones. You may have worked with Tivoli, Commvault, Veritas has one. There's several others out there that for the remote ones, the storage manager will have its own library. When Informix goes to do a backup or a restore, it'll connect through that library to that remote server or remote storage managing server, and then perform the backup to it. So it will use the onbar utility. It's got some layers underneath. It'll then copy that log file or that backup file as it writes it out to the storage manager. The storage manager will do exactly what it says. It manages the storage. So it'll actually keep track of the backups, keep track of what files go into which backups, allow you to do restores off of it. Some of them have different features and utilities, but they all do the same basic thing. The PSM is bundled with there, so you don't need an external storage manager. It's set up to actually back up to a number of different types of storage devices. I'll talk about that in a minute. And it's there, available, easy to use, bundled with the product. You don't have to go out and get another license or anything else. So highly recommend using it if you're currently using ISM and you're on version, you're moving to version 12 or 14, or if you're currently using OnTape, you may want to take a look at this. Or just if you're going from an old version and you want a proper storage manager, or if you're not using any kind of backup utility, please start backing up your data. Everything with PSM uses onbar. If you're familiar with OnTape, but not onbar, it is similar but different. It's more flexible. There's a few more flags to it. It gives you a fair amount more features when you're actually doing your backup and restore. It's also a little more complex. So OnTape is really, really simple. OnBar is a little bit more complex, but not hard to convert to. So benefits. One of the big ones is you can have multiple storage devices. So you can separate out your data stores from your log storage if you need them in different places. You can actually have multiple storage devices for each of the data types. So you can have space 1, space 2, space 3, and space 4. And when space 1 fills, it'll just jump to the next one. And you can set those into whichever is going to be the primary. So that way, if a disk fills up, you don't have to worry about suddenly your backups haven't been running for a week. It'll go to wherever your secondary location is, or past that if you need to have even more levels than that. Manage the limits on storage devices. You can migrate backup data between the storage devices. So if you need to move it around, you can. One of the big features of OnBar is, and PSM completely supports it, is doing parallel backups. So in a traditional, OnTape, you can do everything is single threaded. So you do your root space, your data space 1, your data space 2, your database, DB space 3, et cetera, et cetera. OnBar supports being able to do parallel. So it'll do your root DBS first. Once that complete, it'll do data space 1 through 4 at the exact same time. There is a limit on this where you do need Enterprise Edition to run this. It's technically not licensed with Express or Workgroup. Another big feature of onbar, and this is actually probably the one I would say is the biggest feature of moving from on tape to onbar, is point-in-time restores. When you're doing a restore, you can say exactly to the second when you want to restore. Where on tape, it is to the log. So you do a level 0 restore and then roll forward to log 506. With onbar, you can actually do a point-in-time restore to a particular second. So it'll actually roll through the logs and roll in an individual log up to that exact point. So if you know that at 5:12 yesterday, corrupt data got in your system or somebody messed something up, whatever the case may be, you can actually say, I'm going to roll back to 5:10 and start up from that point. So it is an incredibly useful feature. Certainly has helped out with a number of clients in my consulting experience. So really, really useful. The other thing it allows you to do is actually work with STDIO, standard out devices. So you can actually go out and pipe the data directly to a device or to a stream, basically treat it as a stream out to an external program. So if that's something you need, it'll support. So just a little bit about how this works, and I stole this from the IBM knowledge base. I linked it there at the bottom. So you've got your onconfig file, and we'll kind of go over the flags you look at there. And the primary storage manager will look at the onconfig files to see how it's supposed to be configured. It writes out up in the upper right to the activity log. So all the activity that runs through the PSM, and that does also include commands run, not just backups and restores, will actually be logged to your onbar activity log. So at the top there, you've got your storage spaces, which your onbar utility will actually write out to. The PSM controls the onbar, and it'll actually, the DB space at the top, onbar connects to those. The PSM is actually what controls the whole process, and the PSM will actually have multiple storage pools and be writing the data out there when you do a backup, or obviously pulling from it when you're doing a restore. At the bottom there, you see the storage catalog tables. So PSM actually has an ISAM, flat file database that it actually controls everything, says where the spaces are, what the devices are, what the objects are, etc. So they're all, flat file database that's available. And we'll talk about that in a second. So the on PSM, so the command to run pretty much everything here is on PSM. It's got 4 main flags, and everything will come out from underneath them. -C flags are actually managing the catalog. So you can check it, repair it if there's a corruption in it. You can export it, you can import it, you can initialize it, and you can lock and unlock it if you need to. The -D is actually managing devices. So this is the actual spaces on disk or spaces to an external source, telling PSM, okay, I'm writing a backup, where's it going to? So this is actually where you add devices, delete them, you can list them, you can update them. The big thing is it supports flat files and standard out. For if you're on version 12, those are your options. If you're on version 14, and it may actually be one of the latest versions of 12 as well, I'm not sure if they backported it, it will actually allow you to write out to the cloud. Right now, the Amazon S3 buckets are the biggest one. I would suspect there will be, actually the IBM cloud is supported as well. I would not be surprised if other ones are added down the road. Then you have -O, which is your object management. So these are the actual objects in the backup. So this is, you have an object for, your root DB space. You have an object for your data space 1, your data space 2. You've got an object for log 503, another object for log 504. And then you also have objects for each of the critical files. So with the backup process, once it's completed backing up all your data, it'll actually go through and back up your SQL host, your onconfig, the other IXBAR, the other files it views is critical. It does that automatically. You don't have to do anything for it. And the last one is the pool management. So this is the actual upper level, is what's your data pool, what's your log pool, and there's also an external pool we'll talk about at the end. So the storage hierarchy and how this actually works is you have your catalog, this is your PSM. Underneath you have multiple pools. So you have your DBS pool, so that's where your data goes, your log pool where your logs go. So under the data pool, you see we have two different devices, and then we've got different objects that are backed up into different devices depending on, device one, let's say it failed, it will go to device two and then do the backup 3 to that device. So the catalog itself. So again, it is the base for everything in PSM. If you delete the catalog, you're starting, well, I shouldn't say you're starting from scratch. There are ways to restore it. And again, we'll talk about that in a few. But everything is run off the catalog. Everything, the individual backups, the devices, etc., are stored there. It's an ISAM table. So if you've worked with really old versions of Informix, you have seen this kind of data format, database before. You can, when you are actually backing up your system, I'm hoping you all can hear me now. I just saw a chat thing saying at 11 somebody couldn't see me, and I've been going on. John, am I coming through?
Yeah, you broke up for just a second right before you said the last sentence, but you're back now.
Okay, great. Sorry about that.
Switch, I think.
Just making sure I hadn't been going on with nobody able to hear me.
Now you're good.
So the fourth item here is you need to do separate backups of the catalog. This is really a key piece. It's a really easy task to do. It's on PSM-C export. It'll write it out, looks like a DB export. So what you want to do is periodically have a copy of this. So if you need to restore your system, you've got that easily available. There are ways to rebuild it from scratch if you need to, but it's better to always have extra backups. You can migrate it to another system, so you can export it and then import it into a remote system to then pick up where you left off. So your pools. So these are the data pools. We got the data pool, the log pool, and the external pool. This is the containers that tell you what devices are attached to it. You only have one pool per type of backup, but then you have multiple actual paths or devices underneath it. So storage device pool, what it actually looks like. So you have on PSM-D list. So this is listing the storage devices. So you see here, we've got two pools, the data pool, the DBS pool, and the log pool. Each of those, we have a separate file, so it's actually a directory we're backing up to. By default, if you don't specify it, it'll actually create it under Informix PSM or Informix backups. And then what I did is I left those in place and then added a second device for under Cookspace backups. You'll notice over there, the second column is PROI, so it's priority. So I actually set the highest one to be the Cookspace directory. So that's where all the backups will go to. But if that fails or otherwise has a problem, it'll go into the Informix directory. Obviously, on a production system, I would not want data being written to the Informix directory. You don't want that filling up. But this was just off a test system. So devices, what are we actually looking at there? So files, directories, standard input, and cloud objects. Your options for the priority are highest, high, low, and read only. So if you're actually restoring a backup, you may want to set it to read that device to read only, so you don't accidentally have something else write to it. You can use the priority list to identify where things will go first. You can modify the priority after the device has been added to the pool. So that is a nice feature. Objects. So an object is an individual item from the backup. We talked about it a little bit already. You can actually purge a particular item. We're going to talk about expiring a full backup, but you can actually go in there if you need to suddenly free some space and you've got DB space 5, which is 3 terabytes in size, and you need to free up that space on the disk right now. You can go purge and delete that file very quickly. There's a purge command for it. The other thing you can do is you can actually write individual objects out to a file. So if you need to individually manage them, you can. So just what the PSM looks like with listing the object. So it's -O list. So it'll actually tell you the size, the logical path. So the logical path will be under the device path. You can see when it was created. So you can see all of this was a set of objects on a single level 0 backup. And then the last one entry is another logical log file that was written out. So objects on disk, actually showing what it looks like. So this is, Cookspace backups data is my device. And then underneath it automatically created the directory of my Informix server value. And then under that, it creates directories for each of the spaces that it's creating. So on this one, I've got data DBS, info space 1 through 4, my log space, my physical log space, root space, etc. Each one of those will have the backups in it. So if I do a level 0 now, there'll be one file there. I do another level 0, there'll be a second file there. It'll keep going into the same directories. So it won't keep creating new directories, it'll just keep creating files under them. It also, you notice under the critical files, it'll actually back up your IXBAR, your onCFG, your onconfig, and SQL hosts. So you've got those as well. So onconfig variables. So this is when we're actually configuring the system. This is what we are actually going to tune in onconfig. There's not a lot we need to do. For a lot of systems that are not terribly big, you can leave them at default. So the first one is PSM action log. If you want this separate from the bar action log, the bar ACT log, you can. If you leave it blank, it'll just go into the bar log. Whether you want to split out or not is up to you. Second one is your PSM catalog path. So this is where on disk is your catalog database stored. Default is Informix PSM. The big one, this is the biggest thing you need to configure, is the bar BSA lib path. This is actually the storage manager library and where it is. If you're using Tivoli or using Commvault, you'll have their library pointed here. With version 12 and 14, it comes under the lib file, lib bsa psm.so. So that is the library. So that's what we want to set in that for that path. If you do not set that variable, PSM will not work. So a couple of other options. You can actually set PSM debug. It works the same as var debug. So you'll actually, what level of debugging you want if you need it. You can actually say what the separate debug log is if you need to break it. The PSM DBS pool is actually, if you want to rename effectively the data pool, you can. You can also do this for an environment variable. It's usually best just to have this in onconfig. And the same token you can do with the PSM log pool. So just example of what the variables would be. This is mostly the defaults. I'm using the bar files here, so I'm just using the standard onbar settings. But you see how the BSA lib path is using the lib BSA PSM library. So actually, let's set up our file system. So let's actually configure and set up PSM here. So we're actually going to create a couple of directories, backup/dbs pool, backup/log pool. We're going to change the ownership of 770, owned by Informix. This is pretty standard stuff for most any backups you're working with. The next thing, we do a onstat p list. It'll actually show us the pools we have. So actually adding devices now. So this is actually, we're going to take those directories we just created. We're going to add them as new devices to the device list. So it's on PSM-D add. And then you give it the path, -G, and this is which pool it's going to. -P is the priority, and -T is actually the type of output. So there'll be file, stdio, or cloud. So we're going to add the log pool, the DBS pool, and then we're actually going to list it, and you'll actually see here the DBS pool, we've got 2 devices, and the log pool, we've got 2 devices. I left the defaults in there. I hadn't removed them yet. You can also use on PSM-D to delete, so it's there if you want to prune those old ones out. So we're actually going to test it now. So we've created our pools, we've created our devices, we've, that's it. But we now have PSM running. We'll also set the library and on config. So we're going to do an onbar backup of a logical log. We're going to use the on PSM-O list, so it's showing us the objects, and then you can see here where it's actually backing up logs 7 through 11. You can see them created. You can see the log ID, how big they are, and then if we actually look at the directory backup log pool PSM TCP, which was the server name, levels area number 0 log 11, we can actually see the log backup file there. So doing a full backup, process-wise, this is mostly if you've never worked with onbar before, you do an onbar -B. It's going to start at level 0. You'll see the level 0 root DBS first. Nothing will happen until after root DBS completes. If root DBS fails, it will kill the backup. So it goes through, and you see the archive completion and the log. Normal checkpoint stuff just happened, and because this is from a live system or a test system, but I brought the whole log over. And then what it does down here, because we're doing a parallel backup, you notice that at the same time, the 10:05, 22 seconds, we start a level 0 on both data DBS and data DBS2 at the same time. So both of these are going to back up at the same time. If you're on enterprise, and hopefully you have an enterprise environment, you have your database, your DB spaces on separate disk or separate disk volumes. So by running these in parallel, you have different read threads running at the same time. So it can be a fairly significant performance improvement when doing backups and restores. So again, the on PSM list after we've done a level 0, you see all the level 0 files, a log file, and then the critical files that are backed up. So dumping objects. So if we need to dump a particular object to disk, it's the on PSM-O dump. And then you give it the -o, and you give it the object ID. So back here, you see on the left column, we have the object ID 6 through 16. So if I want to dump just one of those to disk, I can do so by giving it the on PSM-O dump. It'll write the object to a file in the current directory. If you need to look through a critical file, you need to unload something in particular, you can. You need to offload a file because you're out of space. You need to pull out in your data space, you need to pull out a 2 terabyte file, so you can write it to a different file system, run with the space free, and then you can actually add it back into the system later on. I found out, and I actually found this out testing this presentation, before 14.1 XE5 and 12.1 XE15, there's a bug where certain dump files are truncated. I was actually trying this, dumping out the SQL host file, and realized only half of the file was actually there. So it is a real bug that has been patched, but just keep that in mind if you're working with dumping objects. In the real world, you probably will never use the object dump. There's better ways to manage this, but I mention it because it exists. So filters. This works the same way as it does with OnTape or using a different storage manager, but you can actually set up a backup and a restore filter. This will actually pipe the backup or restore process through this particular filter. So it allows you to do a live encryption of the backups rather than having to write it to disk and then run a separate command to do encryption. Same thing, you can have it automatically compress and uncompress the backups. So you don't have to write it out and then gzip it. You can actually have it happen in real time. Obviously, this is going to take more CPU and usually will slow down the backup some, but overall, it'll actually be faster to do it this way than write the whole thing and then compress the whole thing. So it's kind of a trade-off. I will tell you, it does add a little bit of an extra headache if you're restoring. You need to restore to a clean system. You got to make sure the backup filter works and the restore filter are set up exactly the same. So the backups and will all be consistent. So just keep that in mind. But it is there if you want it. So we're going to move servers. How do we do it? And this is either we're moving the server or we're doing a restore on a server because something went wrong. The first one is export the catalog. and move it manually. So maybe you've done a backup of the catalog itself. You're bringing it back to the system that, you're rebuilding a system from scratch, something melted down, you need to start back over, or you're moving to a new system. So you use the OnStat catalog export. It writes it out to, as I said, the same thing as DB export. You've got it available. Then the next thing is we're actually going to move the backed up objects. We can either export them or we can just copy the directories. It just depends on how you want to handle it. Once you actually move to the new server or rebuild your server, you then do an on PSM-C import, and you'll actually be able to import that catalog right back in and be right back up where you're at. If the files are in the same directories, you don't have to do anything else at this point. The system knows it. If you are needing to rebuild the file system, there's a scan utility on PSMD Scan, and it will actually go in, scan the files in your directories, and rebuild the catalog based on that. So exporting the catalog, how do we do that? On PSM-C export, you'll see it created PSM catalog.exp. If you've been working with Informix even since version 5, this is going to look pretty familiar to you. So you'll see each of the different pieces has its own unload file. You can go look at them if you want. I don't know if that'd be terribly interesting, but it's there. So importing it. So there's on PSM-C init, which reinitializes, clears up the catalog, starts from scratch. You'll see me use it on a couple of examples. And then we do on PSM-C import. So it'll actually read the PSM. It'll make sure you're really sure you want to do this, and then we'll reinitialize to where it was before. So if, let's say, we're reinitializing the catalog and we lost the export, something happened to it, it got corrupted on a file system problem, something happened, you don't have it, all you've got is the backup files. What you can actually do is if you create a new catalog using the init, and then, and I should mention, if you've not run PSM before, it'll create the catalog for you initially. You don't have to run this. This is only if you need to reinitialize it. So the on PSM-D list, it'll automatically set up your directories for you if they don't, if you haven't created them before. And then if you actually add devices to the directories that your backups are in, you can actually scan for objects and it will add them in. So in this case, we are actually, for an example, adding the Cookspace backups, whereas where I'd, copied my backups to, I added to the data pool. And then what it's going to do about halfway down, and I should have highlighted this, I apologize for that, you'll actually see on PSM-D Scan. So I'm looking at that directory. And then it will actually go through every file in that directory, as long as it's in a standard PSM format, and actually add them to the catalog. So after I've done the import, it'll actually, this is what the catalog looks like. You'll see these are all the files it pulled back from that import, or that scan, I should say, and re-imports them. The scan and re-import like this would be a critical situation where you don't have the catalog for some reason. But I mention it because it's kind of neat to play with. So, we've gone through, we've done we've pulled those objects back into the catalog. We do an onbar-r, which is restore. And then this is the, nothing up my sleeves. This is just the continuation of the output file. So we do an onbar-r, comes back clean. There's no error messages, do an onstat, and we see that the instance is restored and sitting there in quiescent, ready for us to, move on with life. So external pool. I mentioned it before. It does not exist by default. You have to create it. And the first device you create in the external pool will create that pool for you. I should say it's there, it doesn't list it. It's used to export data. So if we need to export particular data sets, we can, and this is how you do it. So we're actually going to, so we've created an external pool, same way as we do with the data pool or log pool. We get a file or a cloud object or standard in or out. We're then going to use export or do an export. So what we can actually do is the on SM sync utility. This is kind of the control utility for any onbar storage manager. And there's a -E, uppercase E option now. So this is for export. We give it the path that it's going to export to. We give it the generation now. So this is the generation is the backup level. So each backup will be a new generation. So if you've got 3 level 0 sitting in your PSM catalog, you tell it generation 3, it'll restore the 3rd one, or sorry, export the 3rd one. And then if you need to import from it, you just do on SM sync, and that is an uppercase I, not an L. It's just the font decided to not specify, and the -D and the path to read from. And it will go ahead and read those objects from the flat files and actually load them back into the PSM system. The nice thing with this, if you're using the export, it will actually write out the files, for at least the critical files, into exactly the format they were before. So you can use that if you need to recreate the on config, the SQL host, etc. It's a real easy way to pull them back out. So a little example here, we're going to actually start out by doing an export. We're going to do the first generation, and we're going to put it into a data_export directory. So again, the directory is going to be under the external pool, the external pool's device that we're writing out to. I've reinitialized the catalog, so this is nothing up my sleeve. Catalog is blown away. We're starting from scratch. I'm going to add a data pool there, and then I'm going to add the log pool, and finally I'm going to add the external pool. So you see it's the -G AXT pool, adding it as a file, which means it's a directory. And then I use on SM sync -I, so this is import, -P, the directory under the external pool. And then we pull the on PSM -O list, and you see it's all been pulled back in. All of the files are back in. It's ready to go. So I now have those files available if I need to do a restore or something else. So this is a really good way if you need to back up your objects outside of just doing a file system backup to do that. So expiring backups. This is one of the big things as an administrator you want to make sure you can do. You don't want your backup sitting out there forever, especially if you've got, you're dealing with a multi-terabyte database. You don't want 6 months of backups, backed up once a week. That's going to fill your file system really quickly. You only want to keep so many. A lot of times there'll be cold storage where you'll back up from the file system to some external backup device, and then that backup device is, managed separately. So if you need to go back 3 months, you can do it, but you don't have all of those files sitting on your space or on your system. You don't have to go in and manually remove objects. What you actually have is the on SM sync will actually allow you to remove backups either by generation or by timestamp. So if you give on SM sync -G, it'll let you know what generation to delete, or you can give it the -T, and it will delete any objects that are older than that date. This is really useful to write a little script that you give it the -T and then maybe set 2 weeks ago is the timestamp. So, you run that every night, it'll automatically purge anything older than 2 weeks. You don't have to worry about running out of space because it'll always be the same, 4 backups or same 6 backups or whatever it might be. And it will purge them from disk. It'll purge them from the catalog. So you don't have to worry about having to go through a bunch of steps to, go through to find with mtime or, RM, etc., that you might have to do with other backup solutions. The on SM sync command, if you have not worked with it before, I just wanted to note, it can also be used to synchronize the Informix engine sysutils directory or sysutils table and the IX bar with your PSM catalog. So if you've made a bunch of changes, you've done some stuff under the covers, and Informix isn't familiar or aware of it, and things show that they're out of sync, you can do this and it will rebuild the parts you need and allow you to move on with life rather than making you go tweak IX bar manually or go have to do something under the covers with the catalog. This will just rebuild it for you. So Amazon, I'm going to talk about AWS here. there's a little bit of assumption that you've worked with an S3 bucket before. I kind of go through the high-level steps of it. Obviously, you'd want to talk to your S3 administrator. If you have not worked with this before, you can get a free account. S3 you can set up with no cost as long as you're under a certain number of gig of data. I think it's 5, but I could be wrong on that, and a certain amount of transfer. But if you want to play with it, get familiar with it as an administrator, what you do is you actually go through the AWS IAM, which is like the user management console. You create an S3 user and give it relevant permissions. Depending on your environment, exactly what those relevant permissions are. You know, for testing this out, you can just say that there's an option for all S3 permissions, in which case that's fine. Obviously, production, you know, your admins will probably have other opinions, or your S3, your AWS admins. So the next thing you do is on that new user account for the actual S3 user, you create an access key, which will also create a secret access key. Please write these down, or I should say write them down, copy them somewhere. You will need them later on. You log in as the user to the S3 console. So rather than logging in as your admin, you log in with this user. You then will create a new bucket. You go in, give it the settings. Do you want it encrypted? Do you want it logged? Whatever, you know, the other options you've got there. And then under the bucket, you go in and create a folder. So this is where your backups are going to be. And then under that folder, there's an option to copy the URL. So you'll need the URL as well when we're setting up the S3 cloud object. So the URL information we need, it'll be your bucket name .s3.amazonaws.com and then / the container name. Be aware you will need to know your region comes into play. You need your access key and your secret key. So this is how to actually create a pool device. So on stat-d add, that should have been an uppercase D, my mistake. I will fix that before these slides get put into the master list. So you add and then you give it a device name. So this is how, if you need to delete the device later on or change the priority, you'll actually do it by the device name. You then give it the pool. Is this your data pool? Is it your log pool? Is it your external pool? We tell it the priority, and then the -t cloud. So we're telling this is the cloud type. Right now it's AWS or the IBM cloud. Again, I would not be surprised if they add others. I know no extra information on that. It's purely speculation. The next is we give it the URL. So whatever the URL they gave you, you put it here. Provider S3. So this is also where you'd let it know the IBM one if using that. Then we give it the user with the access key, the password with the secret key, the container, which is the container you defined, the region, which is the region name. So that's where I said know it in advance. And so the region name, when you create your S3 bucket, it'll actually prompt you region. Do you want it in Northern Virginia? Do you want it in New Jersey? Do you want it in wherever the AWS data center is that you want it to be? Obviously, you want it near your server. The fewer hops you get, the better it will be. And then the last part is the max part size. So this is the actual object block size that will be sent out to the container. So I'm giving an example, and this is actually this is the actual command I ran when I was creating it. So on PSM-D, and I got the right D on this one, creating it, calling it Amazon Dev, you know, data pool, hi, type is cloud. And then I'm actually giving it the HTTPS of my bucket name, which is PSM2. My username, which is a long string, just give you the 4 characters. Passwords, you know, same thing, 4 characters of the secret key. Container, which is the container name. And then the region was US East 1. So again, when you create the container, you will actually see the region it's going into. And it will actually, besides just saying, you know, Northern Virginia, it'll actually have a region name. So make sure to check that. And then we're telling the block size of 256. So a couple of things here that I found when testing this. It is not the fastest option to go straight to the cloud. I was trying this with an 8 gig instance, so it's a fairly small one. And I did a speed test. So local backup, I was just writing to local disk with 35 seconds. You can, on Linux, you can actually create an S3 mount. So you actually mount an S3 bucket as a file system. So it just looks like any other mount point on the system. When I backed up to that, it took 2.5 minutes. When I backed up straight to the S3 bucket, it took 4.5 minutes. I don't have a real good technical reason why it is considerably slower. I've had other people report to me when they're setting this up in production, they saw the same thing. So most people seem to be opting for treating it as a local file system and just mounting S3 using the S3 file system type. Most of the major Linux distributions will support this as part of the package system. Only took me probably 5 minutes to set up. It's not terribly difficult, but that's probably the way I would go if I want to go to the cloud. Obviously, if you want direct, it is there. We'll see if there are performance or other changes to it in the future, either on Amazon side or IBM's. Again, I know nothing about future plans on this, pure speculation. A warning about this that I also found in testing. Some of the regions have, but not all of them, have started requiring v4 authentication. If you see the error, your authorization mechanism you have provided is not supported, please use AWS4. That means you have chosen a region that does not support that, or supports v4 only. We're dealing with v3 on when dealing with the PSM, so it doesn't support v4, at least not yet. I was testing this on 14.1xc4. I haven't seen notes about it in the later ones. I've not tested on the latest version yet. But I'm mentioning this. If you see that error, go to a different region. Some regions have issued with larger backups. They have reported to me. Again, you want the closest one to your server just to minimize latency. Region is listed in the docs as optional when you're actually defining the device. I found it's not actually optional. If it wasn't set, a number of the Amazon data centers that I tested with would not allow me to connect to S3. I had to provide the region flag. Back to it. The region flag here, second to last option. Otherwise, it did not work. So just mentioning, if you're looking through the IBM docs, I don't really view that one as optional. If you define the container name, I actually saw it in a couple of cases, actually put the storage data in the root bucket. Not entirely sure why S3 was doing this. I just flag it as when you're looking at the bucket, you may see the same thing. Again, I highly recommend for any system you're actually doing this with, you have a separate S3 user, a separate bucket specifically for your Informix backups. So rather than having it intermingled with other backups you may have, the cost of S3 for the storage is going to be the same if you have 2 buckets or 1. So might as well keep it separate. I did just get a question that the parallel backups will not work with Workgroup Edition, correct? It will not. I mean, you might be able to get it to work, but you're going to be out of compliance. Workgroup does not support parallelization. So the same token where Workgroup, you can't fragment a table, you also can't parallel the backups. Obviously talk to your reseller to see if you can get, if you want an exemption, that's all from IBM. I cannot tell you that they ever do that, but if you have any license questions, always talk to your reseller. Gonna jump into questions here. I've got about 5 minutes. I'm gonna show a real quick demo, but I'll open it up if anyone has questions first. Okay, I'm gonna jump into real quick demo. What kind of, I guess, asked what kind of restrictions are there with backup filter? None that, from a licensing standpoint, none that I am aware of. The main thing with the backup filters is you can use a lot of system resources. I've seen people that pipe it through pigs, which is a parallelized version of gzip, so it actually will have multiple threads, getting as much resources as you can to actually do the compression in parallel, which is different from doing the backup in parallel. The compression parallel is basically using multiple threads of gzip to all work together to speed up the compression. However, I've seen that also bring an Informix system to its knees because it's using up all of the system resources it possibly can and leaves the engine with not nearly enough. So hopefully that answered the question. So on this instance, sure we're online. This is a similar copy. It's a test instance. And we're going to go ahead here and list the devices. So I left in the Informix backups. I left in the, created the Cookspace backups data. So we'll actually see it going to the highest one. And then I'm just going to do an onbar backup. So again, this is a very small instance, so it does not take long. So it takes about 10 seconds. Again, really small backup. So if we're going to go ahead and do an object list, and we can actually see here all the backups at 11:56 just occurred. So we can see all the DB spaces were backed up. We can see the critical files were backed up. So we've got everything backed up. We can see the space. So again, this is tiny. And if we go to the Informixter, and I've got mine under the temp directory, I've got both of them going to the bar ACT log. So you'll actually see here in the log where the PSM will write out to the bar log, and each one it'll show you the session that's open, connect to the storage manager, and then each of the things it's backing up. And then once it gets done with the backup, it'll show you it's ready for the next one. And then we'll show you down the line. And the same token, just like any other backups, your on-stack command will show that the archive's completed and that everything is good. -B-L will back up the log. So, and this one showing you the command that was run. It's showing you that's using the PSM, the version for it. And then it shows you it's complete. So, I mean, that's really all there is to it. It's you start up PSM, it'll create your initial, pools. You add some devices to the pool, probably want to remove the default ones. You start using the onbar commands and it backs up for you. Obviously for an enterprise edition, you're going to want to tweak exactly where the files are, what the block size is, etc. If you're dealing with a small instance, this may be all you need to do. And then set up a cron job that once a week, deletes or does the sync purge that, drops anything older than 2 weeks old. Then you've got all your backups running, you're good to go. I will also add just personal preference. I like PSM a lot. I've started using it with a number of my clients. They all seem to like it a lot. However, if I am doing a restore for setting up HDR, so take a full system restore, I want to restore the physical level to a secondary system to set up HDR or RSS, I still use OnTape. Assuming it's not a massive instance, OnTape, giving a single file, you just copy over, just makes my life easy. I'm not saying you need to do it. I'm saying my personal preference is I still will use OnTape for that. Same token, if you have a tiny instance, OnTape may just be easier to manage because you just deal with one file. So I don't want to disparage OnTape. It is still a very useful tool. onbar is the more powerful one. So it depends on your environment, which one is right for you. But PSM is great. It's free. I mean, free with you having paid for Informix. So the question here is, can you do a table level restore with PSM? Oh, that's helpful. At least my demo is done. Yes, you can. So there's a utility, and this works with both OnTape and onbar backups, called ArcChecker. So this will allow you to actually validate your backups. as well as you can actually do restores using it, including table level restores. Normally the system, all the backups are done on the DB space level. Our checker will actually read the entire backup and then figure out where that table is and pull it out. If you're dealing with a large backup, it'll actually, this could take some significant time. I've had some people with really large instances. Our checker takes 3 days just to go through and pull a single table out. So it takes some time. And again, it's because Informix backs up by DB space, which is much quicker because it can just do a binary read straight off the disk. It doesn't have to break things out. If you really need database level backups, there's always DB export, unload, and also using external tables or high performance loader. So there's many options depending on what you need to do. So how can I use standard out with on PSM? And this is the same. You can actually do it with other storage managers. You can do it with OnTape. So I don't know why that popped up. And
sorry to break up the party, Tom. We just about have to go.
All right. Last thing is you just set the -T to stdio. It'll allow you to then, and then you give it, the path will be to whatever device you want to pipe it to. So if anyone has any follow-up questions, I'm with XDB Systems. We do all kinds of consulting and support, including remote DBA 24/7. Last slide is all my contact info. If you have more questions, reach out. Thank you all very much for being on here. So I got one last question on optimization. If you look back at the slide on the on-config parameters for the block size, as well as tuning your disks, those are your two biggest things for maximizing your performance, plus parallelization if you can do it. So thank you all very much. I'm going to stop sharing here, and I think we're ready to break up and get on to the next presentation. So again, thank you all very much for being on. Reach out if you have follow-up questions.
Next session is about encrypted backup, so right on subject.
Oh, excellent. So
see y'all.
yeah,
Thanks.
Thank you.